This is Chapter 2, Textbook Review. We're on page 125, working on the chapter review. A whole bunch of different types of questions. We're going to start on 1 through 8, which is basic simplifying and distributing. So we're going to jump right in here. 3 times x plus 4. We're going to multiply the 3 through it. 3 times x is 3x. And 3 times 4 is 12. Number 2, we put the number that's on the outside on the right now. We just need to make sure we understand it doesn't change anything. It's still being distributed to both of them. So 10 times 2 is 20a, and 10 times a decimal just moves the decimal. So instead of 1.3, it's going to slide over, and it's going to be 13, and the minus carries with it because it's a positive 10. You consider this a negative 1.3. So a positive and a negative is a negative, which we write as subtraction. A little bit longer one here on number 3. So we need to distribute in both spots, and the key is when we distribute this 11, it counts as a negative. So real quick right here, that's 15x plus 35. Now when I multiply here, this is a negative times a positive, which is a negative, so I have to write negative. 11 times x, they combine is just 11x. And when I multiply here, this is the big mistake. Everyone wants to bring down the plus. But it's a negative times a positive, so this is a negative. And I get 66 when I multiply 11 times 6. So combining like terms here, 15, and we have to consider this a negative 11. So 15 minus 11, or 15 plus negative 11 gives you 4x. And then you have 35 minus 66, and that's going to get you a negative 31. So we write that as minus 31. All right, we got a fraction here on number 4. So it still gets distributed times everything. And because 10 and 15 are divisible by 5, you could do this in your head. You would divide by the 5 first and then multiply by the 2. So you can do some quick math in your head here. So 10 divided by the 5, because it's in the denominator, divided by the 5, is 2, and 2 times 2 is 4. And then the 15 divided by 5 is 3, and it's negative, so this will be negative. But you do 15 divided by 5 is 3 times the 2 is a 6w. So let's try that again now in our calculator. So let's say you were using one of these. You hit the alpha button and you hit the x right next to it. That's going to bring up your fraction. So 2 fifths times 10, and you get 4 alpha x. 2 fifths times negative 15. It's negative 6. Now 4 doesn't divide nicely by 5, so that means I'm going to end up with a fraction most likely here. You could do 4 times 2 and get 8, and it's just going to be 8 over 5, and we can leave it that way. But let's try it in the calculator. 2 fifths times 4, and there's your 8 fifths. Now that's 8 fifths w. So I do have like terms here. I have a negative 6. Got to include that minus, negative 6, and a plus 8 fifths w. So these need to go together. Here's a time where I would just say grab the calculator. Okay, so negative 6 plus, you hit the green alpha button and the x button right next to it. Put in your 8 fifths, and you get negative 22 fifths. Now that's with the w, so we're going to put that up front. So negative 22 fifths w. And I still have a positive 4, so it's plus 4. Now in the answer key, they wrote it as 4 minus 22 fifths w. That's fine too. If you look, plus 4, negative 22 fifths, negative 22 fifths. So the order doesn't have to be like that. I do prefer to have the variable up front. That's kind of like the standard form, but they're both correct, and you can see the answer key gave it this way. So it's not like if you write it this way or this way, it's wrong. So either way really is fine. Okay, moving on. Number 5. Okay, I see a couple things here. First of all, I'm going to do 4 times y, and I'm going to get 4y. I'm going to do 4 times 13, and it's a negative, so I get negative 52. Now, you could go ahead and distribute here, but I noticed something. 3y minus 3y, anything minus itself, 3y minus 3y, that's going to be 0. Right? If it said 3 minus 3 is 0. 3y minus 3y is 0. So it's going to be 6 times 0, so you're going to get actually a plus 0. If you do it out, you're going to get an 18y, and you're going to get a negative 18y. Well, those will go together and cancel each other out anyway. So this actually all goes away, and this is your final answer. You're done. Number 6, throw some decimals in there, but if you got a calculator, no big deal. Notice they all have x's. We're not distributing anything. We're just combining like terms here. If I was trying to do this in my head, I would put the negative 4 and the 17 together first. That's like 17 minus 4. That's 13 plus 1.5. So 13 plus 1 would be 14. Add the 0.5. So this is 14.5x. And feel free to do that in your calculator if you want to. Number 7. Pretty similar. Just combining like terms here. So a 7 and a negative 2, if you put that together, that's like a 5x, and combine it with a 13, and that's 18x. And last one from this section, number 8. Negative 6m, 5m, negative m. That's a negative 1. So negative 6 plus 5, that would be a negative 1m, and you combine it with another negative 1m. Negative 1 plus negative 1, that's negative 2m. Okay, now that's all your basic distributing, combining like terms, mostly with positives. Now we moved on in lesson 2.4. You can see right here, lesson 2.4, to dealing with opposites or negatives and adding that to that. So let's do a couple of those. So we're on 13. This reads the opposite of 7a plus 4. So you can just rewrite it as the opposites. So this is a positive, this is a positive, you just change them to negatives, which is the same thing as distributing a negative 1. So multiplying by negative 1 just changes the sign, so you get a negative 7a and you get a negative 4. Technically, you could write plus negative 4, but I do prefer simplest form. So instead of writing plus negative 4, we're just going to write minus 4. And that's what you see in the textbook answer key as well. Okay, 14, the opposite of 3h minus 7g plus 8. All we're going to do is distribute the negative and change all the signs. That's all it's going to be. So positive 3 becomes negative 3. Negative 7 becomes positive 7. Positive 8 becomes negative 8. There's no terms to combine. The h and the g cannot combine. They're different variables. Okay, we add a little more here. 1 minus z. Before we can do anything, we need to distribute this just like we were doing up here. So the 1 is going to stay. Comes here. This becomes a negative 1, so minus 1. And the opposite of negative z is positive z. This becomes positive z. This is a negative times a negative. It's a positive. You write plus. Combine your like terms. 1 minus 1 is 0, so they go away. Final answer here is just z. Okay, 16. 7x minus 4x minus 8. Same idea. We have to distribute before we can do anything else. So leave the 7x alone. Opposite of positive 4 is negative 4x. Opposite of negative 8 is positive 8, or a negative times a negative is positive 8. Combine like terms, and that's 3x plus 8. Okay, on to 17. One and 1/2, which if you wanted to write as 1.5, you could, minus 3/4 minus y, which if you wanted to, you could write it as 0.75 minus y. Those are easy fractions to convert to decimals. So first thing I would have to do is distribute, so I'm going to leave the 1.5 alone. Opposite of positive 3/4 is negative 3/4. Opposite of negative y is positive y. So if I was going to do this in the calculator, I honestly would turn 1 and 1/2 to 1.5 and turn this to 0.75. Otherwise, trying to put this in your calculator can be a little tricky. I will kind of show you how you would do it. If you wanted to put 1.5 in as a mixed number, you can do 1, and then watch what happens. When you try and put a fraction next to it, you end up with them putting the 1 up top, and you're like, well, how do I get the 1 out front? So what you want to do is you actually want to put the 1/2 in here, and then scroll all the way to the left of it, and now you can put your whole number 1 in front of it. So now you have 1.5 minus alpha x 3/4, and you get 3/4. So we get 3/4 plus y, and that's a perfectly good answer, and that's what you'll see in the textbook. I prefer the y up front, so if you put y plus 3/4, that's fine too. And if you'd done this all as decimals, it would have been 1.5 minus 0.75, and instead of 3/4, you would have had y plus 0.75, which is a perfectly good answer. And if you put the 0.75 in front, that's fine too. Okay, so 3/4 or 0.75, both good. Just to go back and talk about answers as fractions and decimals, if the fraction gives you a nice decimal that you don't have to round, it's perfectly acceptable to give the decimal answer or the fraction. If the fraction gives you a nasty decimal, so if you had something like 7/9 and you did 7 divided by 9, and you get this long decimal that doesn't actually end, they've rounded this last number, it's 0.7 repeated, okay, then we're going to leave that as 7/9. But 3/4 is just 0.75, nice decimal, perfectly acceptable answer. All right, and last one from this section is 18. Just a lot to do here. Just need to distribute twice. So key is count that as a -5 when you distribute here. So positive 3b, negative 6, negative 15, negative 10e. Now, 3b, there's no other b's. Negative 10e, there's no other e's. Those have to stay separate. The only thing that can combine is just the whole numbers that don't have any variables. So when you put those together, that's going to be negative 21, which I like to put at the end, whole numbers at the end. Technically, we want to put these in alphabetical order. So it's going to be 3b minus 10e minus 21. But you could put this in any order that you want. If you wrote negative 10e minus 21, now this is positive 3b, so you would have to have a plus 3b, but that's perfectly fine. Okay? But wherever that 3 is, it better have a plus in front of it. And wherever the 10 is and the 21 is, better have a minus or a negative in front of it. So if you move them around, you need to make sure that the positives and the negatives stay with them. But this is the best answer. Alphabetical with your variables. Any remaining whole numbers go at the end. Okay, after 18, looks like we went to 28. So we're talking about related facts, kind of going to your triangles here. Talked about those fact triangles. So we're starting off with D equals C times G. So if we're making one of those triangles and we're talking about multiplication and division, multiplication on the bottom and division up top. So C times G equals D, that's what they gave you here. So you could switch it around, you could say D equals G times C. You can always go the other direction. And if we're reading from top to bottom, we're going to be dividing. So D divided by G equals C. In the other direction, D divided by C equals G. And if you wanted to, just put numbers in there. If it's confusing for you with variables, put in numbers that make sense. So I'm going to make D 10. So I can't just pick random numbers for C and G. They got to be two numbers that actually multiply to 10. So let's say 5 times 2. So how else can I write this? I can say 10 equals 2 times 5. And then I can say, if I'm following this order, G was the 2. So 10 divided by 2 equals 5, and 10 divided by 5 equals 2. So those are all the related facts. We are just expressing this with variables, which can be a little confusing at first, but this is all we're doing. If this makes sense to you, we just need to translate it to variables, and that's what we've got right there. So we also have 29. We're looking at addition now. So we have 1/2 equals 1/6 plus 1/3. If we put that in a fact triangle, addition goes across the bottom. So the 1/6 and the 1/3 go down here, and the 1/2 goes up top. So the other way to add is to just switch the order. So 1/2 equals 1/3 plus 1/6. You don't even have to do the math. Don't let the fractions bother you when you go from top to bottom. It's subtraction. So 1/2 minus 1/3 equals the other one, 1/6, or 1/2 minus 1/6 equals 1/3. Now this looks a lot easier when you've got basic numbers, but the fractions are still going to hold true. So you always read these from top down, or you go across and add them to get the top. Okay, next was 32. We're going to use related facts to find the value of the variable. So on 32, we have 2.6 equals 13 plus a. So if we're going to use algebra, we're trying to get a by itself. So that means the 13 needs to go away. So it just says a equals, not 13 plus a equals, just a equals, and there's my answer. So to get rid of a 13, I need to get it down to a 0. So I minus 13 to get it to 0. But the rule here of equality is I have to do it on both sides. So it goes away here because it's 0, and then this side will give me the correct answer, and I get negative 10.4. The other way to solve this is thinking with a triangle. These are being added, so it's 13 and a down here, 2.6 up top. So what you want to do is you want to write this where the a is isolated. So you're going to do 2.6 minus 13 equals a, and that isolates it. And now go ahead and combine those, and you're going to get negative 10.4 equals a. So using related facts, isolate the variable, or using algebra, isolate the variable. Either way, you want it to be a equals. The a needs to be isolated by itself, and then you've got your answer. 33. Same idea, but with multiplication and division. So x times 0.8. This is multiplication. In order to get rid of it algebraically, to get out of multiplication, you have to divide. So we're dividing by 0.8, and you always have to do everything on both sides when we're talking about solving an equation. So anything divided by itself is 1, leaving you just a 1x. So that's how we end up with an isolated variable when we have multiplication. It's divide by the number, because anything divided by itself is 1, so it's 1x. Must do it on both sides, so 56 divided by 0.8 is 70. Now, if you were going to do this with the fact triangle, if that actually makes a little more sense to you with the fact triangle, here's your multiplication, which goes across the bottom. So x times 0.8 equals 56. So if we wanted to solve this, we want to read it with the numbers together. So 56 divided by 0.8 equals x, which, again, notice that's exactly what we did. It's just a different strategy. And then when you divide that, you're going to get your 70. All right, 35. Reciprocal. So we got to keep these two straight. Reciprocal and additive inverse. Those are kind of the two we're going to talk about a lot. So reciprocal has to do with multiplying. It's what number do you multiply it by to get 1? Basically, all you do is flip the fraction. So if we started with negative 5, we want to think of it as a fraction, so over 1. So the reciprocal, just flip it, is negative. You got to keep the negative. It can go out front, 1/5. Because if I multiply this straight across, I'm going to get, first of all, a positive, and I'm going to get 5 on the top and 5 on the bottom, and that's 1. So all you do is take this, flip the fraction, and that's your reciprocal. And then next up was number 47. So just a quick check on additive inverse. So additive inverse is the number you add to get 0. So another way to say additive inverse is the opposite. So if I have negative 7.536, what would I add to it to get 0? I would add positive 7.536. So the additive inverse of any number is the opposite. It's the number when you add them together, you get 0. And then last but not least, number 58. A number puzzle question. Want to make sure we've got these going into the test. So if you go back to the directions here, we're not actually picking a actual number. We're going to let n be the number that we're starting with. So we're going to do this algebraically. If you look at the end of this, it says you always end up with 3 times your original number. So if your original number is just called n right now, that means 3 times the original number is 3n. So when we complete all of our simplifying as we go through this, expressing it algebraically, we need our final answer to be 3n if this is going to be true. You always end up with 3 times your original number. It looks like that. So step 1 is pick a number that's n. Step 2 is add 11. That's easy. That's n plus 11. Don't write 11n. That would be multiplying by 11. Adding 11, n plus 11. Now we're going to multiply by 6. So what I'm going to do is put the finished product down here, and I'll do any extra work over here. We're going to multiply this by 6. That looks like this. You can't just multiply the 6. You have to multiply all of it, which means you're distributing. So this times 6 and this times 6. That's 6n plus 66. Next step, subtract 12. So I'm taking the 6n plus 66, and I'm subtracting 12. So in order to combine like terms, I'm just going to ignore the 6n because these two don't have variables. They can be combined. They are like terms, and the 6n does not have another like term. So I'm just combining this, and that would be 54. So I still have the 6n. So it's 6n plus 54. Now I'm going to divide by 2. So I'm taking this whole thing, 6n plus 54, and dividing by 2. So you can do it individually here. Both numbers need to get divided by 2. 6 divided by 2 is 3, and the n stays with it. And 54 divided by 2 is 27. Make sure both numbers get divided by 2. Subtract 30. So from this, I have 3n plus 27. I'm going to subtract 30. Again, that doesn't affect the n. Not a like term. Only affects this. So 27 minus 30 is negative 3, and I still have a 3n. So it's 3n minus 3. And then the last step is to add 3. So I'm adding 3 to this. Like terms combine to make 0. Negative 3, positive 3, that's 0. All I'm left with is 3n, which is what I wanted as I looked ahead. 3 times my original number. I started with n. I finished with 3n. That's 3 times my original number. I know that I've done everything correct.